All right, so these are the notes for solving polynomial equations. So we're finding solutions and zeros. So it's going to be kind of what we've already been doing with the factoring, but now we're going to add in the solving part. So it says, you have used the zero product property to solve factorable quadratic equations. You can extend this technique to solve some higher degree polynomial equations. So for example 1, solving a polynomial equation by factoring. So here we're going to factor through our normal methods. So you first look, is it in standard form, which it is. Then you look for your greatest common factor. In this case, they all are divisible by x. And then this would be x squared minus 4x minus 5. Then we're going to take a look at our trinomial in here and see if it's factorable. First off, it's not a special case, but since that doesn't work, we're going to try the x method. And two numbers that add to -4 but multiply to -5 are going to be -5 and +1. So one thing I did forget to do was set this equal to 0 because we are solving. So now my factors are going to be x times x minus 5 times x plus 1 set equal to 0. Now we set each one of those factors equal to 0. And then we just solve it. So this is already solved. We add the 5 over and x equals +5. Subtract the 1 over and x equals to -1. All right, now for the next thing, it says, this next part right here is called multiplicity. And it kind of talks about what happens when the solution is approaching the x-axis. So as the solution hits it, what actually happens to the graph, right? So our first thing it says, when a factor of x minus k of f of x is raised to an odd power, so odd being 1, 3, 5, 7, 9, and so on, the graph of f is going to cross. So it crosses the x-axis at that actual x-intercept. Now, when a factor of x minus k of f of x is raised to an even power, the graph of f touches the x-axis but does not cross the x-axis at x equals k. So if you have an odd power like x to the first, third, fifth, and so on, then your root, when you get to the x-axis, you actually go across it. Whereas if it's even, your graph, it actually touches and then it churns, right? So an example here is my x-axis. So if I had an odd power, when it hit the x-intercept, it would cross it. Whereas if it was an even power, when it hit the x-axis, it would touch it and turn away. Now, if it's coming from the top, it would touch it from the top and then turn away. All right, so example 2 says, find the zeros of f of x equals -2x to the 4th plus 16x squared minus 32. Then sketch a graph of the function. All right, so we're going to factor this through our normal ways. So first, we take a look, is it in standard form, which it is. We look to see, does it have a GCF? In this case, it looks like the GCF is going to be -2. That's going to give me x to the 4th minus 8x squared plus 16. Is it a special case? Well, perfect square, okay? So we're going to attempt to see if it works. So the square root of this is x squared. The square root of 16 is 4. We multiply it, we get 4x squared. If we double it, we do get that. So we use the middle symbol, and we square it. And we'll set this equal to 0 because we are going to be solving it in a moment. Okay, now from here, this is another difference of two squares. This is a perfect square, and this is a perfect square, but it's squared. So we're actually going to write it out twice, just so we can get all of our factors correctly. So again, this is going to be square root of that, plus minus, and this one's the exact same, so it's going to be x plus 2, x minus 2. Now we notice that these are together, so -2, this would be x plus 2 squared. There's this one, so it's going to be x minus 2 squared, since there's two of them. And right now, that's where we're at. So what I'm going to do now is I'm going to take these and solve them. So if it's squared, I don't really need to set x plus 2 squared equal to 0. I can just look at the inside and say x plus 2 is equal to 0. And when I subtract the 2, I get x equals negative 2. That would be one solution. I can take x minus 2 squared, which is just x minus 2 equals 0, add the 2 over, and x equals positive 2. Now, if we're talking about the sketching the graph, let me kind of show you how I would do that. So first, let me talk about the x-intercepts. So right now, my x-intercepts are x equals negative 2 and x equals positive 2. Now we're going to talk about that multiplicity. So what was the power raised to? So if you remember right here, they're both actually squared, right? So this is 2 and this is 2. And what is the behavior at the x-intercept? Well, even means that it's going to, right here, touch and turn. So I'm just going to put T for touch and turn. This one's also squared, so it's also going to touch and turn. Okay. So let me go ahead and draw a rough sketch of a graph here. This will be the x-axis, and this will be the y-axis. We know we have two intercepts. One is at negative 2, and one is at positive 2. Now, one thing that actually does help when you're graphing this is to find the y-intercept. So if I go back to this original equation right here, if you recall from previous math lessons, you would remember that the y-intercept is, it's going to be 0, y. So what that means is every x value, you're going to make it 0, right? So this would be 0, 0. So I'd have f of x equals 0 plus 0 minus 32, which means that your y value for your y-intercept is negative 32. So we actually have the y-intercept as 0, negative 32, which is somewhere down here, okay? Now, you notice I'm going to be pulling a lot of prior knowledge that you should already know. Okay, so let's talk about end behavior, right? Because right now, all I know from this graph is that I have two x-intercepts and I have the y-intercept down here. So if I was talking about end behavior, I have to look at the leading term, right? So we look at this right here. So if you notice, it's even, and the leading coefficient is negative. So if you remember from before, even means they're both facing the same direction. They're either going to be facing both up or both down. Negative means they're going to be facing down. So I know from to the left, it drops, and to the right, it also drops or falls. So when I make this rough sketch, I'm going to start from the bottom left. I come to my first x-intercept at x equals negative 2, and multiplicity is 2, so I touch it and I turn. At the y-intercept, I just cross through and come back up to this x-intercept. And here again, at 2, it is multiplicity of 2, so we touch it and we turn. And we go down. And you'll notice that helps follow the end behavior, right? To the left, it falls, and to the right, it falls. All right, let's take a look at the next page. Okay, so the rational root theorem. So the rational root theorem, it says if f of x equals this polynomial a sub n x to the nth power plus ... plus a sub n x plus a sub 0 has integer coefficients, then every rational solution of f of x equals 0 has the following form. So yeah, that's a lot there. But what the rational root theorem pretty much helps us to do, it helps us to find possible solutions for any polynomial function, right? So how do you do this? Well, this is very important. It says p divided by q. So p represents the factors of the constant term a sub 0. So the constant at the very end, without a variable, that is your actual p value. So you take the factors of that, whatever it is. And then q is the factors of the leading coefficient, which is this right here. This is actually q, okay? So now you know where that p is going to be the constant divided by, so p, all the factors of p divided by all the factors of q. And then right here it says the rational root theorem can be a starting point for finding solutions of a polynomial equation. However, the theorem lists only possible solutions, right? So every solution you come up with using the rational root theorem is not necessarily a solution. It's just a possibility that it can be. So in order to find the actual solutions, you must test values from the list of possible solutions. And the way you're going to test them is by synthetic division. All right, and let me go ahead and go through an example right here on how to do this. Okay, so first off, it says using the rational root theorem, find all real solutions of this polynomial. Now, first off, what I do notice is there's 4 terms, and we've talked about this before. If there's 4 terms, you attempt to factor by grouping, right? So I'm gonna show you how this looks over here real quick. So if I were to group these first 2 together, x cubed minus 8x squared, I would factor out an x squared and be left with x minus 8. And in the second set, they actually have nothing in common, so it would just be a positive 1. And when we did the factor by grouping, these parentheses were the same, right? So at this point, we know that does not work, factor by grouping, so we go to the rational root theorem, okay? So the first step we're going to do with the rational root theorem is we're going to list all possible solutions. All right, so the first thing I'm going to do, I'm going to identify my constant and my leading coefficient. So my constant is right here, the number 20. And my leading coefficient is a number at the very front of my leading term, which is going to be a 1. Okay, so we're going to go through all the factors that make up 20. So we have 1, 2, 3 doesn't work, 4 does. Now at this point, 4 times 5 is what makes 20, 2 times 10 makes 20, and 1 times 20 makes 20. And for the leading coefficient, the only factors of 1 are actually just 1. Now, when we list out our possible solutions, so I'm going to show you this real quick on how I can do it and why I'm doing what I'm doing. So first off, what we do is we actually take the factors of the constant term right here, and we divide them by the factors of the leading coefficient. So let me give you the first example. So if I did 1 divided by 1, I would get a positive 1, okay? But there's also something else you can do. You can also do negative 1 divided by negative 1, and you can also get positive 1. So why I'm doing this and showing you this is that it's just not 1 divided by 1 is 1. It's also negative 1 divided by negative 1 is positive 1. So when you actually write your possible solutions, when you do 1 divided by 1, you're going to put plus or minus 1 because the positives divided make positive 1 and the negatives divided also make positive 1. So when I do 2 divided by 1, I don't just put 2, I put plus or minus 2 because those are the possible solutions. 4 divided by 1 is plus or minus 4, then plus or minus 5 when you divide by 1, and so on until you finish this up. Okay, so now these are the list of all my possible solutions. So it's not just 1, 2, 3, 4, 5, 6. It's actually 2, 4, 6, 8, 10, 12. There are 12 possible solutions to this polynomial here. Okay, so that's how I got the list of possible solutions. All right, for step 2, you're going to test for a solution / factor by synthetic division. So if you recall from one of the prior lessons, in order to prove that something is a solution or a factor, when you do synthetic division, the remainder must be 0, okay? So in this case here, you'd have to test, you start at 1, and you do synthetic division. If the remainder is not 0, you go to the next one, then you go negative 1. If it's not 0, you keep going until you find the remainder of 0. Now, for me to help me get through this a little bit quicker, this is what I suggest you do sometimes. So if you're at home and you need to kind of get through this a little bit quicker, what I suggest is you just type in the equation into like Desmos or something. So I'm going to type in x to the 3rd power minus 8x squared plus 11x plus 20. And now right here, I can actually see my solutions. I'm not going to use this to cheat. I'm just going to use this to help me find my solutions so I can get through synthetic division a little bit quicker, right? So right here, I see my solution is 5, 0, right? And I can see all the other solutions, but I'm interested in how I need to do the math. So I'm just going to use 5. So 5, 0. So when I test a point, you know, you could tell right here, if I would have done 1, it wouldn't have worked. But if I would have done -1, which is one of the possible solutions, it would have actually worked, right? So actually, let's just use -1. That was one of the quicker solutions. So if I did -1 and I did synthetic division, I would start with this polynomial here. So x cubed, x squared, x, and constant. So my coefficients are 1, -8, 11, and 20. Okay, and then we go through synthetic division. Now, if I was actually testing, when I did the first one, I know the remainder would not be 0. This one, the remainder should turn out to be 0, but we're going to verify that. -1 times 1 is -1. Combine, you get -9. Multiply is 9. Combine is 20. Multiply is -20. Remainder is 0. So what this does is this shows me that -1 is a factor, or actually -1 is a solution, and x plus 1 is a factor, okay? So now you notice I circled it because I'm going to come back to this and remember that when I write my final answer, this is a part of my solution set. All right, so I have a next step. We are going to write the polynomial. So you're going to write the polynomial. If it is a quadratic function, you can factor or quadratic formula to solve. If not, you must repeat steps 1 and 2. Okay, so that's actually kind of important, right? So if you're working this problem out and you find out one of your points and then you rewrite your function, your polynomial, if it's a quadratic, then you can actually solve it either through factoring or the quadratic formula. Because the factoring doesn't work, you have to do the quadratic formula. But if it was like x to the 4th, and when I did this, I got x cubed, then I would try factor by grouping. But if that didn't work, I'd have to do the whole rational root theorem again, starting from my new polynomial. But in this case here, if you recall, remainder, constant, x squared. So my polynomial function is x squared minus 9x plus 20. We set that equal to 0. All right, for step 4, we're going to... Actually, I'm sorry, I put step 3 and 4 together. Step 3 was to write the polynomial, which I did. And step 4 was to see if I can factor it or not. So we'll put step 4 over here. Sorry about that, putting those two together. So I'm going to factor it. I'm going to attempt to factor it. So I do the x method. So -9, 20 divided by 1. So it looks like -5 and -4. So I get x minus 5 and x minus 4 is equal to 0. And then for my last step right here, I'm going to take everything and I'm going to find all real solutions. Okay, so we take each one and we set it equal to 0. So x minus 5 equals 0. X minus 4 equals 0. So this one we add 5, we get as x equal to 5. When we add the 4, we get x is equal to 4. And don't forget your original one that we circled at the very beginning, x equals -1. So you can write it like this, or you can actually put it in order or list it out as one solution if you want. That's really up to you. Braces to represent a list of answers. I would accept this, and if you want to write like this, that's actually up to you if you want to. All right, so there's how you do the rational root theorem. Let me keep going. All right, for this last stuff here, it says, in example 3, the leading coefficient of the polynomial is 1. When the leading coefficient is not 1, the list of possible rational solutions or zeros can increase dramatically. In such cases, the search can be shortened by using a graph. So, testing 12 of them is quite a lot, so you always hope they come within the first 3 to 4. After that, it does get a little tedious because it's just more work. Okay, So this is again going to be the rational root theorem. So step 1, we're going to list all possible solutions. So the way we do this is first we need to identify what the constant is and the leading coefficient. So in this case, the constant is negative 24. And my leading coefficient is 2. So the factors that make up negative 24, and the negative sign, I'm not going to worry about that because it's going to be plus or minus, so it won't make a difference. We have 1, 2, 3, 4, and then 4 times 6, 3 times 8, 2 times 12, and 1 times 24. Now, your possible solutions can increase dramatically. So let's see how this looks. So the factors that make up 2 are going to be 1 and 2. Now, if we know if we take the constant factors and divide it by 1, it's itself. So 1 divided by 1 is plus or minus 1, then plus or minus 2, plus or minus 3, and I'm just going to rewrite them all. I'm dividing by 1. All right, now this is where it gets different. Now you're going to take each one and divide it by 2. But at this point here, you don't want them to repeat. So if they start repeating, you can stop, right? Because or just make sure you go through them, and if they repeat, you don't need to write them down. So 1 divided by 2 is 1/2, so that's plus or minus 1/2. 2 divided by 2 is 1, so I don't need that one. 3 divided by 2 is 3/2. 4 divided by 2 is 2. 6 divided by 2 is 3. And you can see this is 4, 6, 12, and 4, 6, and 12 are all there. So I had 4 new possible solutions because of the 2. All right, step 2. We are going to use synthetic division to find one of our roots. So here is my polynomial, x cubed, x squared, x constant. So we have 2, negative 3, negative 50, and negative 24. All right, from here, I already put it in a graph because I didn't want to spend too much time. So that's what it says. In such cases, use a graph to figure it out quicker. So I typed it into my graph, and I saw that 6 should be a solution. So I'm going to show synthetic division to prove that it is. So I dropped the 2. 6 times 2 is 12. Negative 3 plus 12 is 9. 6 times 9 is 54. Combine those, you get 4, and then you get positive 24, which is 0. And here you can see my remainder is 0. So that proves that this is a solution and that x minus 6 is a factor. All right, from here, step 3, we are going to write the polynomial. So this is remainder, constant x and x squared. So we have 2x squared plus 9x plus 4. In step 4, we're going to go ahead and go over here and factor this. So we have 2x squared plus 9x plus 4, and let's set that equal to 0. So x method, we have 9 on the top, we're dividing by 2, and then 2 times 4 is 8. So 8 plus 1 is 9, 8 times 1 is 8. This reduces to 4. So we have x plus 4, and 2x plus 1 is equal to 0. Then for our last step, we're going to go ahead and solve these. So we set each one equal to 0, so x plus 4 is equal to 0. 2x plus 1 is equal to 0. So if we subtract the 4, we get x is equal to negative 4. Subtract the 1 divided by 2, x equals negative 1/2. And again, don't forget our original solution, x equals 6. And those are my 3 solutions for this polynomial. All right, on to the next example. So example 5 says using zeros to write a polynomial function. Write a polynomial function f of least degree that has a leading coefficient of 1, and the zeros are 3, 2, and negative 4. All right, so this one's not too bad to do here. So let's do this real quick. So step 1, we are going to write our intercepts as solutions. Write zeros equal to x, right? So we'll say right here, x equals 3, x equals 2, and x equals negative 4. Okay, so write the zeros equal to x. Step 2, we're going to unsolve. So when I say unsolve, we're just going to move this. How do we bring 3 over here? We subtract it. How do we bring 2 over here? We subtract that as well. And then we add the 4. Now it does say our leading coefficient is 1, so I can put a 1 in front, and I'm going to write y equals. Okay. Step 3, we're just going to multiply it out. And once we multiply this, that's going to be our final answer. Okay. So y equals, I'm going to put x plus 4 first. Then I'm going to FOIL this out. X times x is x squared. X times negative 2 is negative 2x. Negative 3 times x is negative 3x. Negative 3 times negative 2 is positive 6. So we have x squared minus 5x plus 6. And then we're going to FOIL it out one more time. X times x squared is x cubed. X times negative 5 is negative 5x squared. X times 6 is 6x. 4 times x squared is 4x squared. 4 times negative 5x is negative 20x. And then 4 times 6 is 24. Then we get to our final answer. We have 1x cubed. We have negative 5x squared plus 4x squared, which is going to be negative x squared. We have a 6x minus a 20x, which is going to be negative 14x. And last, we have a plus 24. And there is our final polynomial. All right, and I think that is going to conclude the notes.